Hello everyone, let's talk about another medium problem on Leetcode today. Sort the jumbled numbers, Leetcode 2191. In this problem, we are given a zero index integer array mapping, which represents a mapping rule of a shuffled decimal system. Mapping I is equal to j means that digit I should be mapped to the digit j in this system. The mapped value of an integer is a new integer obtained by replacing each occurrence of a digit I in the integer with mapping I for all I more than equal to 0 and less than equal to 9. Then we are also given an integer array nums. We have to return the array nums sorted in non-decreasing order based on the mapped values of its elements. And then they have given some nodes as well. The elements with the same mapped value should appear in the same relative order as in the input. The element of nums should only be sorted based on their mapped value and not be replaced by them. Okay, and then they have given some examples as well. In example 1, we are given a mapping array and nums array. So let's write down the mappings first. We can see that at 0th index, the value is 8. So 0 is mapped to 8. Then 1 is mapped to 9. Then we can see that 2 is mapped to 4. Then 3 is mapped to 0. 4 is mapped to 2. 5 is mapped to 1. 6 is mapped to 3. 7 is mapped to 5. 8 is mapped to 7. And 9 is mapped to 6, right? So these are the mappings. Now they have given nums array as well. So we will start transforming the values in nums using the mapping array given to us. Now we can see that 9 is mapped to 6 and 1 is mapped to 9. So 991 becomes 669. Similarly, we can see that 338 becomes, so 3 is mapped to 0. So it becomes 0, 0, and 8 is mapped to 7. So 0, 0, 7. So it is equal to 7 because leading zeros don't make sense for the number. And finally, we have 38, which actually maps down to 3 is again 0. So 0. Then we have 8. 8 becomes 7. So this is also equal to 7. Now when we sort these mapped elements, they become 77669. But we have to return the original elements, not the mapped values as per node 2. So we have to sort them based on the mapping, but we have to return the unmapped values. So both 7s occur first, but we return 338 and 38. Because as per node 1, when the elements have the same mapped value, we should return them in the same relative order as they appear in the input. So 338 appears before 38. So we will return 338, 38, and finally 991. And now that we have seen the example, let's jump into the solution space. So first thing we will need is a mapping function, which can actually convert the number to the shuffled decimal system as per the mapping values for digits 0 to 9. Then using the mapping function, we will create a new array of mapped values based on the input array nums, similar to what we have done here. So 991, for example, becomes 669. Now let's define the mapping function. For that, we will actually convert the number to a string. So for example, first we convert 991 to string, and then we actually go through the number character by character and find the equivalent value in the mapping array. So for example, for 991, we first see character 9. We actually replace it with 6. And then again, we see second character 9. Then we again replace it with 6. And finally, we see 1. We replace it with 9. So that's how we will get 669. And then convert it back to number, which will take care of the leading zeros. For example, in case of 338, in example 1, the mapped value is 007, but when we parse it to integer, it will become 7. And once we have these mapped values, we can actually use them to sort the array. And because we want this custom sorting, we can use a comparator interface in Java to do that. For more details on the comparator interface, please refer to my previous video, Sort Array by Increasing Frequency. And I will be also making a dedicated video on comparator interface soon, and I will link it to this video. Now coming back to this problem, we have a mapped values for the nums array. So 991 becomes 669. Similarly, 338 becomes 7 and 38 also becomes 7. So now comparator interface will actually use the mapped values and sort the original nums array. So we know that in Java, comparator interface takes two values, A and B. So now we can just compare them based on map that we will have. So we get the mapped value for A and compare it to mapped value of B, right? So this is how we will just do the ordering. But we have to handle the case when the mapped values are equal. So then we have to take care of the node 1, where they say that if the values are equal, then they should appear in the same relative order as in the input. So to address this issue, instead of using the elements in the comparator, we can actually use the indices. Now we have to just compare the mapped value of the numbers at index A and B and see if they are equal. That is, their comparison returns value equal to 0. Then we can actually do A minus B, right? Because we are comparing now based on the indices. So we want the element with the smaller index to come first. So that keeps the relative ordering same. So this is one way, but do we really need to do this? And the answer is no, because the sorting algorithm in Java is already stable. So what we mean by stable is if two objects with equal keys appear in the same order in the sorted output as they appear in the input array, then the sort is stable. Otherwise, the sort is unstable. So some sorting algorithms are stable. For example, insertion sort, merge sort, bubble sort, and some algorithms are not. For example, heap sort, quick sort. And that was one of the reasons why Java developers actually implemented sorting algorithm as merge sort rather than quick sort. So that is the reason we don't have to use indices here. But if we are not sure about the sorting internals of different programming languages, in that case, we can actually do the comparison based on the indices. But this time I think we were lucky. Now let's jump to the code part. So first, let's create the map to store the value between the elements of nums array and the corresponding mapped values. Let's call it map nums. Now we will loop over the nums array and try to fill in this map with number and corresponding mapped value. And we can create a map value function where we can pass in the number and the corresponding mapping array that is given to us. So now let's define this function. So first thing we will do is we will convert the number to number string. So we can use toString on integer to do that. And then we will create a corresponding map number string. And then we will loop on the number string character by character and append the mapped value to the mapped string. And we can get the mapped value for a corresponding digit at the index c minus 0, where c is the ASCII digit and 0 is also the ASCII digit. So for example, when we do ASCII digit of 9 minus 0, we will get 9 in this case. And once this is done, we return the map string parse as integer. And now we convert the nums array of primitive integer to the corresponding array of integer wrapper class, because unfortunately comparator interface works with the objects only. So to convert it to the corresponding wrapper class, we can convert this array to a stream and then use a box to convert it to corresponding wrapper class and then convert the stream back to array. So now once we have this integer array, we need to sort it, right? So we can just say arrays.sort and pass in the box array and define the comparator on two elements A and B and do integer.compare on the corresponding mapped values of A and B. So what this will do is this will actually sort our integer array based on the mapping values from the map numbers. And once we do that, we can actually define the sorted array as an output. Now we can actually loop on this boxed array and convert it back to the primitive array. So we will just say sorted nums I is equal to nums boxed I. That's it. And Java automatically converts the wrapper classes to primitive class and we just return the sorted nums. Now let's run this code. Okay, what's the issue? It says that no suitable method found for stream. I should pass nums to it. That's the reason. Sorry about it. Now let's run it again. Awesome. Now let's submit this code. Cool. In terms of time complexity, it is O of n log n, where n is the number of elements in the nums. And the reason for this is we are doing this comparison based sort. So that takes O of n log n time. And in terms of space complexity, it is O of n, unfortunately, because we are using this nums box array, which is an integer class array, and we need it for the comparator interface. So that takes O of n space. I hope this video was useful to you. If it was, please like and subscribe. The code link is in the description. Thank you. Have a nice time.